So power is another triangle that we'll use. So where we've done Ohm's law in a previous PowerPoint and lesson, so now we're discussing power. So electrical power is the rate of doing electrical work or the expenditure of electrical energy. The formula for power is obtained by using the power triangle as shown on the right. So we have P over VI. From the triangle, we can see that power is equal to volts times amps, or P equal VI for DC only. So since Ohm's law, V equals I squared R, I times R, by substituting for I times R for V in the power equation, we get P equals I times R. So basically one of the things that we use for AC power, which we'll go to in a little bit, when we're doing some of these other calculations, we can use the other one. For AC, P equals I squared R. Or if we do a little bit, transpose that, we do P is equal to V squared divided by R. So these are some of the little calculations that we'll be using, and we'll go through more of these in practice, and I'll give you the worksheet for this as well. So example number 1, calculate the power in each resistor and the total power of the circuit. So the total power of the circuit is the current and the voltage. Yeah. So we times those together. So we get 100 times 2 amps, 100 volts times 2 amps. We get 200 watts. Now we can double check that and we can look at this. So now if we have the power dissipated by the resistor number 1, which means we'll get the power number 1. So what that actually means is we're looking for here. We're looking for the power from this. Yeah, the power dissipated by R1. So we have I. So we have I squared times R. So 2 squared times 30 gives us 120 watts. And it's exactly the same for this one. We have I squared, which is still 2 in here. So 2 squared times 20, which gives us 80 watts. And what hopefully the next slide will show, that 120 plus 80 gives us 200 watts. And voila, proving that when all the individual power in the circuits are added together, they will equal the total power. Now, this is really good practice for you to get into. So when you do the Kirchhoff's law on your series and parallel circuits, by double checking, filling in little tables and charts, you're checking to make sure that the calculations that you've done are correct all the way through. So this is a slightly different way. Since V equals IR and the voltage across R1 is V1, so we get 2 ohms times 30, we get 60 volts. And then we put that into P equals V squared R. So we have 60 volts squared divided by 30. I hate that when that little box, we get 120 watts. So it's just different ways of doing the same calculation. And it's just that similarly, we could do this on the other one. So we got 40 volts across R2. We do the rest of the calculations, V squared times 40. So 40 squared divided by 20 gives us 80 watts. So it's just different ways of checking your work. Just different ways that we can go into and have a look. So